Hi everyone. Today we're going to study orthogonal trajectories. Given the graphs, when all the curves in a family capital G of x, y, and c sub 1 equal 0, these are the graphs in blue, intersect orthogonally or perpendicularly all the curves in another family, say capital H of x, y, c sub 2 equals 0. Here are the graphs in red. The families are said to be orthogonal trajectories of each other. If dy over dx equals f of xy is the differential equation of one family, then the differential equation for the orthogonal trajectories of this family is dy over dx equals negative of 1 over f of xy. Here is the working rule to find the orthogonal trajectories. Step 1. Differentiate the given function with respect to x. Step 2. Replace dy over dx equals negative of dx over dy. Step 3. Eliminate the given constant, if any, using the given equation. Step 4. Use the method variable separable or homogeneous or exact to solve the differential equation. Example 1. Find the orthogonal trajectories for the family of curves ax squared plus y squared equals 1. Step 1 is to differentiate with respect to x. So we have here 2ax plus the y squared becomes 2y times dy over dx equals 0. Step 2 is to replace dy over dx by negative dx over dy. So the equation in step 1 becomes like this. And we regard this now as equation number 2. Step 3. Eliminate the given constant using the given equation. The constant here is a. Now look at the given equation in here. If we isolate a, it will be equal to 1 minus y squared all over x squared. Then we substitute the value of this a to equation 2. This is our equation 2. The a is there. So this equation 2 becomes like this. The value of a is now changed. Looking at our equation here, the x and the x squared in the denominator can be cancelled. So the new equation becomes like this. We simplify further the equation by dividing by 2. So we have now this 1 minus y squared all over x minus y times dx over dy equals 0. Step 4. Let us use variable separable to solve the differential equation. First, this negative y dx over dy we can put on the right side. So it becomes like this. From negative, it becomes positive. Now, let us separate the variables. The y variables goes to the left, while the x variables goes to the right. So it becomes like this. The quantity 1 minus y squared multiplied by dy all over y equals x times dx. Then we integrate both sides. On the right side, we can get the integral of x dx easily. While on the left side, we're going to separate the integrand. So this 1 minus y squared all over y becomes like this. 1 over y minus y. Then let us take the integral of each of the terms. The integral of 1 over y is natural log of the absolute value of y minus integral of y will be y squared over 2 equals, the right side is x squared over 2 plus c. This is now the final answer. Example 2. Find the orthogonal trajectories for the family of curves 2x cubed minus 3x squared plus 3y squared minus 7c squared equals 0. Step 1. Differentiate with respect to x. We have now the 6x squared minus 6x plus 6y times dy over dx equals 0. Step 2. Replace dy over dx by negative dx over dy. So the dy over dx here becomes dx over dy, and we put the negative sign in front. Let us simplify further by dividing the equation by 6. So the new equation becomes x squared minus x minus y times dx over dy equals 0. Step 3. We are now to use the variable separable method. In our equation here, this negative y dx over dy, we will transpose to the right to make it positive. So it becomes like this. Now let us separate the variables. The dy goes on the left side, while all the x comes to the right. So we have now this dy over y equals dx all over x squared minus x. Then we take the integral of both sides. On the left, we can simply get the integral of dy over y to be the ln of the absolute value of y. While on the left side, we're going to factor out the denominator to be the quantity x times x minus 1. In here, we're going to use the partial fraction method. We can show that this 1 over x times x minus 1 is equal to a over x plus b over x minus 1. Let us multiply this equation by the LCD, which is this value x times x minus 1. So we will have 1 is equal to a times the quantity x minus 1 plus bx. Then we say that the equation is true for all the values for x. So let us set x to be equal to 1, then we will get b equals 1. We set x equals 0, then we will get a to be equal to negative 1. So let us rewrite our right-hand side. This 1 over x times the quantity x minus 1, we can show that this is a over x plus b over x minus 1. Since we have now the values of a and b respectively, we will substitute in here. So the right side becomes like this. Then we will get the integral of the fractions respectively. So the integral of negative 1 over x dx will be the negative of ln of the absolute value of x plus the integral of 1 over x minus 1 dx will be ln of absolute value of x minus 1. Then we write plus c. This is the final answer. Example 3. Find the orthogonal trajectories for the family of curves y squared minus x squared plus 4xy minus 2cx equals 0. Step 1. Differentiate with respect to x. So we have 2y times dy over dx minus 2x plus 4 times the quantity. For this 4xy, we're going to apply the product rule in here. So we have x times dy over dx plus y times 1 minus the derivative of this 2cx will be 2c. So we have this negative 2c here, then equals 0. Next is, we are going to distribute this constant 4 to the terms inside the grouping symbol. So we have 4x dy over dx plus 4y. Next thing to do is to group the terms with dy over dx. We put the dy over dx as common, and the remaining values will be 4x plus 2y, and the quantity is multiplied by dy over dx. We regard this as equation 1. Then step 2, we replace dy over dx by negative dx over dy. So in this dy over dx, it becomes dx over dy, and we write the negative sign in the front. We regard this now as equation 2. Step 3, we eliminate the given constant using the given equation. In equation 2, the constant is this c. From our given equation here, we can isolate first this negative 2cx on the left, and the remaining terms we will transpose to the right. So it becomes like this. Simplifying further, let us divide the equation by x. The left side becomes negative 2c equals negative y squared over x plus x minus 4y. And then we substitute the value of negative 2c to equation 2. Our equation 2 is here. This negative 2c now becomes this value in the grouping symbol. Then we will remove the grouping symbol and combine like terms. So the new equation becomes like this. We can simplify further by making this dx over dy alone on the left side. Let us transpose this negative x and this negative y squared over x to the right. So we have this equation now. See here that we can combine the right side in one fraction only. So it becomes x squared plus y squared over x on the right. Let us isolate now the dx over dy, meaning the coefficient terms of our dx over dy we can put as denominator to the right side. So it becomes like this. Let us now invert the equation so that we will have the dy over dx. So we have here this dy over dx equals the negative 2x times the quantity 2x plus y all over x squared plus y squared. We can see that the equation here is a homogeneous differential equation. And let us regard this as equation number 3. Step 4, let us solve this equation using homogeneous method. We let y equals vx. If we take the derivative of this with respect to x, we will have dy over dx equals v plus x multiplied by dv over dx. Next is, we substitute the values of y and dy over dx to equation number 3. This is our equation number 3. So the left side becomes v plus x times dv over dx equals, we now change all the y by vx. So it becomes like this. We can simplify our numerator and denominator respectively. In our numerator, we can combine this negative 2x times x. In our denominator, we can factor out the common term, that is x squared. And in this equation, we can cancel out the common x squared in the numerator and x squared in the denominator. The simplified form of the right side is now like this. Negative 2 times the quantity 2 plus v all over 1 plus v squared. Next thing to do is the v on the left side we will transpose to the right. So it becomes negative v. Let us combine this fraction with the negative v. Let us show here that the v as a whole number can be multiplied by 1 plus v squared all over 1 plus v squared. Let us multiply this v with this quantity 1 plus v squared, and then let us combine the like fractions. So we have like this. Next thing to do here is to multiply this negative 2 to the terms inside the grouping symbol. And let us simplify this negative of the quantity v plus v cubed. If we do that, we can combine like terms, and the numerator is simplified into negative v cubed minus 3v minus 4. Look at the terms of our numerator here. All are negatives. So we can factor out the negative 1 in our numerator. So the numerator becomes the negative of the quantity v cubed plus 3v plus 4. When we separate the variables, the equation becomes like this: v squared plus 1 multiplied by dv all over v cubed plus 3v plus 4 equals the negative of dx over x. Then we take the integral of both sides. On the right side, it is easy to take the integration. But for the left side, we will use the substitution method. Remember that we can take u is equal to v cubed plus 3v plus 4. And we can simplify the left side into 1/3 times the integral of du over u. The right side is now equal to negative ln of the absolute value of x plus the constant c. And then we can write the final answer. For the left side, we can simplify this into 1/3 of ln of the absolute value of the quantity v cubed plus 3v plus 4 equals our right side. This is the final answer. I hope you learned something from this video. See you again next time.